These are the frequently asked questions for Algebra 2, and this is for section 9 for day 2. I'm going to look at find the sum of each finite series here. And as we look at this group of problems, we could use a formula for this one because that is an arithmetic series right there. So you could use our S of n equals n over 2 times the quantity a sub 1 plus a sub n formula for that one, for this one, because those all follow that pattern that we've seen from our arithmetic series, where you have an n value sometimes multiplied by an integer or even a fraction, and then a constant hanging out in back. So those follow that theme that we get for arithmetic answers. Because this last one we could always write as negative n plus 7. That would fit that pattern. However, 24, that's just not going to fit that pattern. So that one we would have to write out by hand. Same thing with number 25. And it is just the first 9 terms. So, I probably wouldn't grab a calculator and just write them out anyway and see what they are, especially when you see what this turns out to be. So let's put a 1 in here and see what we get. Negative 1 to the first is negative 1, and negative 1 times 2 is negative 2. Then we put a 2 in there. Well, negative 1 to the second power is just going to be 1, and 1 times 2 is 2. Put a 3 in there. Well, negative 1 to the third power is going to be negative 1, and we get a negative 2. And you realize, hey, wait a minute, this is going to happen like this again and again and again. So we have negative 2 plus 2 plus negative 2 plus 2 plus negative 2 plus 2 plus negative 2 plus 2, and let me see how many terms I have. 1, 2, 3, 4, 5, 6, 7, 8. So one more. And we see that will give us 0. 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 And our answer is negative 2. So again, don't go for the calculator right away. You want to evaluate these formulas and get those terms so that you can see, is there anything nice going on with this? And in this case, absolutely, we see that we have this nice properties of 2 and then a negative 2 that are going to cancel each other out as you work through the problem. Then number 26, this one we could use our arithmetic formulas for as well, because that follows the pattern that we have seen with our arithmetic formulas. It's kind of that y equals mx plus b pattern with the arithmetic. Again, I'll say arithmetic so that I don't lose anybody, but the arithmetic series, when we have those, we notice, hey, it's kind of mx plus b. That's what it is. So on the next page, use a graphing calculator to find the sum of each series. Not a fan of this. You already know that. This is very, very clunky, but I will go through this with you. So what we need to do is get into that list feature. So second, stats, and then we have to arrow over once until we get to the operations, and then one more so that we get to math, and it's number 5, which is going to be the sum. And then we have to tell it the sum of what? What is the sequence that you're trying to use here? So second list, over to ops again for number 5, sequence. And now we want to tell it what all of this is. And because this is the color calculator now, this leads you through all of the little pieces that you need. So we want 2n minus 3. So that will be a 2, second, and then, that's hard to make out up here where those alpha keys are. N is over the log button. And it must not have taken 2 alpha n. There we go. So 2n minus 3. And enter. Now I need to tell it my variable was n, so alpha log, so that it knows that I'm using that. And I want it to start with the lower limit, and in this problem the lower limit was a 1. And the upper limit there is a 50. and we are going by ones, and that puts it all in there for us. Now, we had to type that in by hand on the normal TI-84 Plus Silver editions. It's the colors that will do that for you. And then we'll press enter, and there it is, 2,400 for the sum of that series. Then, let's see, I had another one down here, number 31. So we will look at number 31. Again, second list, over to math. We wanted to find the sum, number 5. Second list of the sequence, number 5. And now we need to define all of this again, so I'll clear that out. And this one is negative 4n plus 32. So negative 4, second, oops, not second log, maybe that's what I pushed before when I didn't mean to. Alpha log, there we go. Negative 4n plus 32. The variable is n. This one is starting at 5 and going to 73. Pretty obviously we would not want to write all of those out. By ones, paste, it's all in there for me. And negative 8,556. So it's a possibility to use the calculator, but when we have just a few terms, or actually even up to about 10 terms, we're going to want you to go ahead and generate those and get those. So I think I'm going to shut the good old SmartView down because that seems to slow up everything else that I do. We had the answers to those. Now, 33. A meeting room is set up with 16 rows of seats. The number of seats in a row increases by 2 with each successive row. The first row, 12 seats. What's the total number of seats? So start thinking, all right, I'm going to need the sum of the first 16 rows, where I know the first one is 12. But again, I need to know how many seats are in that last row, that 16th row. So we really cannot get away from writing the rule when we deal with arithmetic. So the first row is 12, and they are adding 2 each time, that's D. We will go ahead and distribute and get our formula so that we can use that to figure out how many seats are in the 16th row, and that's going to be 42. Now you can find the sum, because you have the first row, you have the last row. So this will be 8 times 54, and that will be 432 seats. So you use that series formula to figure out what it is you're missing, and then once you know that you're missing something, you grab the arithmetic rule and figure out, how do I get it? You know, what is the information I need? What do I have? And go from there. 34 says determine whether each list is a sequence or a series and finite or infinite. All right? Sequences do not ask us to add everything up. Sequences are just listings of numbers. They're separated by commas. So I look at 34, and this is a sequence. Then they wanted to know if it's finite or infinite. And remember, 3 dots say this is going to go on forever. So this is infinite. Number 37, I know it doesn't look like addition, but it is. Because really what they did was they simplified the addition of a negative. So they are adding these together, which means this is a series, and 3 dots, this is infinite. So series, they're asking us to add them all up, put them all together. Sequences are just going to be a listing of numbers separated by commas. Finite, it stops. There's no dots. Infinite, we see the 3 dots, leading us to believe that it's going to go on forever. All right, number 40. Number 40 says each sequence has 8 terms. Evaluate each related series. And I look at 40 and the question I have is, is this arithmetic so that I can use my rules? So we take 3 halves and subtract 1 half, and that would give us 2 halves, which is 1. And then we realize, oh yeah, that's what they're doing every time here. They're adding 1. So that means I can go ahead and use my formula for a finite arithmetic series. So we need the sum. It's at 8 terms, so 8 over 2. The first one is 1 half, and the 8th one, right up there, 15 halves. So this will be 4 times 16 halves, which is 8, and that will give us 32. I'm always a little suspicious when they give us too much information. They gave us everything here. But that is all that we have to do for number 40. Number 46, a little bit different. This one says in a 20-row theater, the number of seats in a row increases by 3 with each successive row. The first row has 18 seats. So A is just write an arithmetic series to represent the number of seats in the theater. I need a rule in order to do that. So I'm going to go with the rule, and the first row is 18 seats, increasing by 3. So 18 plus 3n minus 3 will be a sub n equals 3n plus 15. So big old sigma, 3n plus 15. And then we wanted to talk about rows 1, 2, 20. Right there. B, find it. Find the total seating capacity of the theater. So it's a good thing we wrote that rule, because we're going to need that information. All right, we know there are 20 rows. We know the first row is 18, but we need the 20th row. So that means we're going to put a 20 right in there. 3 times 20 is 60, and 60 plus 15 is 75. And that allows us to complete our formula. And we've got all the numbers in there that we need. So S sub 20 is going to equal 10 times 93, and the 20, all 20 rows totaled up will give us 930 seats. So that's all the seats that are in there. Now, C is the problem child here. Front row tickets for a concert cost $60. After every 5 rows, the ticket price goes down by $5. What is the total amount of money generated by a full house? So, I do my planning, and I figure out what I really need to do is I need to figure out how many are in each of those increments of 5 rows. I already know S sub 20 is 930. Because then I can use subtraction to figure out how many seats there are of each price that they gave me. So I'm just going to start with S sub 5 up here, and that would be 5 divided by 2, where the first row is going to be 18. And then I will need to use my rule again, and let me rewrite that rule down. The rule was 3n plus 15 to find how many seats are in that 5th row. So 3 times 5 is 15, and 15 plus 15 is 30. So the sum of the first 5 rows is 120 seats. 10 rows. 10 over 2, and then the first one is 18. Plug a 10 in. You get 45, and that comes out to 315 seats. 15 divided by 2, the first one is an 18. Put a 15 into the formula. 45 plus 15 is 60. And that comes out to 585. So now using subtraction, I can figure out how many seats are in each piece here. So 930 in the total house, well, 930 minus 585 comes out to 345. Then, subtracting here, 585 minus 315 is 270. 315 minus 120 is 195 seats. And then, of course, we have those 120, which are, I guess, considered the front row seats. So each of those 120, they're going to charge $60 for. And then these rows will be a little cheaper because they're a little further back, so those will be $55. These will be $50, and these will be $45. So then you grab a calculator and you punch in 120 times 60 plus 195 times 55 plus 270 times 50 plus 345 times 45, and that gives you $46,950. Now here's something to think about. That was only 20 rows. Imagine sitting in the Target Center, how much money is made off of tickets, especially if somebody like Paul McCartney is playing, who can get up to $250 a seat for tickets to that concert. So a lot of money that can be made in just one evening of entertainment. Number 47, we have a supermarket, and it says they display cans in a triangle, and we can see that triangle over here on the side, and it says write an explicit formula for the sequence of the number of cans. All right, so we have arithmetic because we see they're adding 1 every time, and that top row was a 2. So a sub n equals 2 plus n minus 1, and a sub n equals n plus 1. So there is our explicit rule right there. B says use summation notation to write the series for a triangle with 10 cans in the bottom row. All right? Well, we're going to use that n plus 1 rule right there. And then what we have to do is figure out, well, if I put a 1 into my formula, that's going to give me 2. And they want 10 cans in that last one, so I better put in a 9. Because that's the only way I'm going to get that 10 generated as the last one. And then C says, suppose the triangle had 17 rows, how many cans would be in the 17th row? Well, that's not a biggie, just use the rule. That's going to be 18. And then D says, could the triangle have 110 cans? Exactly. Could it have exactly 140 cans, and explain? Well, I don't know. I'm going to have to do some trying here and see what happens. So I'm going to try 15. I don't know how many are there, but I'm just going to get a feel for it. So that would be 15 divided by 2, 2 for the first row, and then of course I'd use my little formula and say, okay, 15 plus 1, that's 16. So the sum of the first 15 is 135. Okay, well, it's not going to get to 140. We can see that, but I'll go ahead and try a little smaller one so we can see whether or not we're going to get to 110. So I'll try the 14th. Sum of the 14th rows, the first 14. And 14 plus 1 gives me the 15 for this piece. Again, it just comes back to your arithmetic formula right here. And that is 119. So that's not going to get down to 110. And just to make sure, I guess I would check S to the 16th just to make sure that it's not going to give me 140 cans. So that would be 16 divided by 2, and 2 plus 16 plus 1 is 17, and that ends up being 152. So in answer to their question, no, it's not going to get there. And we have all the math here to show that it's never going to perfectly be the two numbers that they asked us to check for here. So we can move on. Next, evaluate each series to the given term. So 2, 4, 6, 8, I notice they're adding 2, so I would want to write the rule here. So I would have 2 plus n minus 1 times 2. Here's my first term going up by 2, So that will be 2 plus 2n minus 2, gives me a nice little short formula here, 2n. Now, we want to evaluate it to the 10th term. So the sum of the first 10, where we know the first one is a 2, but the reason I needed the rule was to see what is that 10th one going to be. And of course, 2 times 10 is 20. So that will give us, that doesn't look like an S, that will give us 5 times 22, which is 110. So compared to our seating and our grocery store example, this one is awfully short and sweet, and that will do it.